Hello, everybody. This is Chase Scannell. This is Luis Villegas and Mr. Ko. This is our project for this semester, which is a smart water irrigation system that works off an Arduino. So let me go over to the next slide real quick. So the purpose of this project is that during this time we have, we're generally like busy people when we're working and stuff like that. We're not at home, just quarantined. So as we're working, we're worried about like what's happening at work, what's happening, with our family, friends, that kind of stuff, and things could be forgotten. And one thing that could be forgotten is our lovely plants at home. So I'm pretty sure someone has experienced this either once or twice in their lifetime where they just completely forget about a plant that they've been growing for like the past like couple of weeks. They just completely forget about it just because of all like life and it's being busy. And they come in, they're like, wait, I have this plant that I've been growing for like the last couple of weeks. And it's been like maybe hopefully not more than like 2 or 3 months. And you'd hope that it'll still be alive. But with this project, you won't ever have to worry about watering your plants like yourself again. So with the help of our Arduino, we could make our Arduino just water our plants for us instead and have us worry about other stuff that's more important in our lives while still maintaining a healthy growing plant in the background. So let me go over to my next slide real quick. Oh, okay. So let me pause right here. Let me go towards our e-portfolio real quick. So we already went through this. Okay, so this is also a build of materials. Let me widen this real quick. That's better. Okay, so our materials are pretty simple. We have an Arduino Uno. We have a moisture sensor, a relay that goes to our motion sensor, and some jumper wires that we connect to a breadboard. Of course, also provided are the chia seeds and the water pump and the tubing that will pump the water to our box. So pretty much these are all the pictures when we first got all of our materials, took pictures for here. And for this, we reused an old milk carton. So I cut like the top of it off a little bit, just so that way I have like a little flap for it to, let some sun in. While if there's times where I want to retain the moisture, I can close the flap and the soil will be harder for it to dry out. And here's obviously our picture of our Arduino itself. So let me go to the next one. Diagram's pretty simple. Pretty much we have our moisture sensor hooked to our Arduino in this fashion right here. We have it set to one of the inputs, and then our outputs that will going to our relay. Output will pretty much send a signal high to the relay. The relay will recognize that this is a high signal, activate the relay, and we'll start our motor, or our water pump, sorry. Okay, so enough talk. Let's get on with our video presentation, which I'll go back to here. Present. And I'll let this is a pre-recorded demonstration. I'll let past self just present. So hopefully you guys could have the audio turned up. Hopefully you guys have your audio turned up for Zoom. And I'm going to start in 3, 2, 1. Right. Hello, everybody. This is Chase Scannell from ESYS61 and 62, presenting my water irrigation system project. So right here is my chia seeds that I've been growing for about 2 to 3 weeks now, and it's grown pretty decent so far. We've been getting a lot of growth recently, especially these past couple days with these seeds right here just recently sprouting. So let me give you a brief overview of what the system is right now. So as you can notice right here, we have this tube right here that will pump water from this water reservoir that we have in a pickle jar, and the whole thing is in a milk container that I've cut the top off. And so this is all being hooked up with an Arduino Uno and a few sensors and a relay. So this program, what it does is that it is currently connected to my computer through a Blink server, which you can see up here is my Blink server status. So it's currently on. So what this allows me to do is that I'm able to control this system through my smartphone. So I have my app pulled up right here, and I've created a simple gauge meter and a water button. So currently the water pump that I have set up right here doesn't work with a water pump to it. It will draw too much current from the USB port and will shut off the Arduino itself. So I'm sorry there couldn't be a proper demonstration here, but just try to imagine that there's water flowing through these tubes and will be dripping down through these little holes right here that I've made cuts into. So let me demonstrate right now. So this pin is wired up to this relay and will turn on this motor right here. So I have the app right here. I'm gonna hit water. You hear the relay click on and off. You can hear the motor running right here. So just pretend like there's water flowing through these tubes. So just to show out, this is a real-time gauge of this moisture sensor right here. So if I stick this moisture sensor into the soil right here, as you can see, the moisture level will rise up. Okay, and then if I take it out, the moisture level will drop down, because about 580 on the sensor is about room temperature, and about 400 is about the moisture for about soil. Now this number will get smaller once it's put into water as well, of course, because water is very moist. Okay, so this is my ESYS61 portion of this presentation, but to present my this is my ESYS62 part of the presentation. Alright, so I have two sets of code, one that works with the Blink server code right here, and I also have a different set of code that works for an fully automatic. So whenever it senses the moisture sensor gets to a certain range, it will automatically flip on the relay and will start watering. So right here, okay, it is done. So right now, if I take this out of the soil, you can see the relay activates, the motor turns on. I put it back in the soil, the relay shuts off, and that's pretty much it. So once again, take this out, shake the water off, relay turns on, pump starts going, put it back in, and so on. So this was just to simulate me taking the moisture sensor out of the soil, was just to simulate once the soil gets dry. Okay, and that's pretty much the whole system. I have everything just in a cardboard box right here, just for demonstration purposes only. But yeah, that's it. Thank you guys for watching this demonstration. It sucks that I couldn't have a live demonstration of the water that was coming out through these tubes, because it looked pretty cool up until about a couple hours ago, where the motor unfortunately stopped working with the water inside. So yeah, thanks for guys watching. All right, see ya. All right, and that concludes our demonstration. So let me pull back to my screen right here. I'm going to show off a little bit of data that's in our ePortfolio a little bit. So let me share my screen here. And as you see, this is day one. So I added a little bit of plant growth enhancer. You kind of see with like this little white powder on like the 1/2 of our soil. So this is day one. Day 2, 3, you know, after like day 4, I was like, I've seen other videos of some other plants or some videos of people having more success on day 4 where they're already growing. But I guess on day 6, I see a little bit, tiny bit, just like in like the little crack of the soil. I assume this is because this is like, deeper in the soil, must be more moist. So the seed must have absorbed more of the water as it was in deeper the soil in between that crack. So day 7, day 8 now, get a little patch going, day 9, and then this is where it really starts, growing real fast now, because now day 10 is just this patch right here, and then only one day later, all this decides to pop up as well. So I was really impressed, kind of blew my mind on the last couple days. And this is the day that I filmed the video. And then after a while, this is what it looks like. So I forgot to take pictures for a couple of days after that video presentation. But coming back to this plot, the soil over here, because I just forgot about it. So this is what it looks like today. So this is day 18. This is today. I took this picture today, and I'm pretty happy with the growth of this so far. I might have to transfer this over to a bigger pot eventually, and maybe I'll have to buy a Arduino and test out this fully automatic soil system that I got going on in my backyard. So yeah, that's pretty much it for our demonstration for our automatic water system, and that pretty much it. I think that's it. Here's our analysis conclusion. Works cited page right here as well. So we followed the instructables guide slash other website, the electroschematics.com. We kind of referenced that a little bit with our diagram as well. Helped us wire all the sensors and the relays together with our project kit. Okay. And that's it. Anything else that you guys want to say?
Comments from the gallery.
Very nice.
Thank you, William.
Well, thank you. Thank you.
Mm-hmm.
So I have a question. The question has to do with the pump. So when did the pump demonstrate some challenges?
The day that I recorded that video, exactly. So it was the day that I got my tube set up. I had the tube, I made like a little hole on the side of the box.
Yes.
And I also made a hole in the cap itself. So that way it would be one, floating like tube right over the soil.
Yes.
So I made the holes in the tube. I tested the tube before, and I made sure that like the water was pumping through. I was just like, okay, this works. But I realized that there was like a lot of water like pumping out through like one hole of the tube. So I was looking at different like connectors for our tube. So I would have to like slice the tubes open, put like maybe a couple T connectors in, have like multiple sources of water where it would go into the soil instead of it being pulled up in one area of the soil.
Understand, yes.
Yeah, so Home Depot or Lowe's didn't have exactly what I was looking for, just because my luck, apparently. they mainly have stuff for like, housing, not really stuff for like small projects like this, I guess. So I was just like, okay, well, I got to work with what I have. So I have an X-Acto knife. I made some holes in between the tubing. The concept was to just have the holes drip out the water, and it worked for a little bit, right? So it was dripping water at like a pretty decent rate. The water was flowing in. I also had the other connection of the tube flowing back into our water source, so that way it wasn't, all it being squirted out at like a very high pressure. I just wanted it to like just drip down, just make it look really nice and subtle. But about an hour afterwards, the motor, I tested both motors because we got 2 motors in our kit. I was just like, why is this not working? And Actually, I have a video right here. Let me go back to my. Am I still screen sharing? Yes, I am.
Or
Okay. So let me share computer sound. So let me do this. So this is when I was troubleshooting everything. And so this is my microphone, and you'll see like a little indicator light right here that indicates that it's powered on through USB. And this weird phenomenon, every time the relay would come on, my microphone would stop getting power. So that's why in a previous meeting beforehand, my mic kept on shutting off, and Zoom was like, "We can't hear you." I was like, "Oh, what's going on here?" So this is breaks down a little bit. You can hear the relay flicking on and off with the microphone also getting its power shut off the same exact time. So wasn't quite sure why that was happening. I have it connected to a powered USB hub. So I was just like, this shouldn't have like this kind of issue because it's going off like its own power source from the wall. It's not like it's taking it off like one USB port off my computer. So I was really confused. Didn't know exactly what was going on until like a couple hours after. And it was really hard to try to diagnose this exact issue just because I was just like looking through a bunch of other forums saying like, oh, Arduino not supplying enough current or USB. I thought something was wrong with my computer itself. So I was digging through there, just trying to find every single possible way that, you know, I just thought it was more complicated than just like the motor that just went bad, I guess. So yeah, this is my little write up right here that describes the motor issue that I was having earlier.
that's a really nice page, and that is part of your e-portfolio as well.
Yeah, I can add that to my e-portfolio as well. Yes.
Yeah, if it hasn't been, it's a critical part of your e-portfolio, because as we play it back, and we hear that you had encountered a challenge with the motor presenting itself, or the pump presenting itself with some sort of a challenge, it's important that this is included. So it says, yeah, you addressed it. This is how you addressed it, and this is the outcome. So back to my question regarding the pump. How is it powered? Where is its power source?
Oh, the power source, it's directly off the Arduino itself. So off the, let me pull it up right here. I could tell you which pin it's at.
Do you have the specifications on the milliamp draw for the pump?
Let me double check. I'm not too sure.
But your relay that does because you had a program, you had a relay that was clicking on and off, and the relay is controlled by the Arduino, yes?
Yes.
Okay, what's the other side of the relay hooked up to?
The other side of the relay is just, it goes from Arduino, gets its power from Arduino, goes to relay, and then motor gets, it flips off it goes from the normally open switch to the COM port. And once the relay goes on, okay.
All right. And chronologically, when did you encounter this pump issue? Was that a week ago, 2 weeks ago?
So about like, it was Thursday where I recorded this video. So it was exactly on Thursday last week. But when I got my pump, I was checking it, making sure it was okay, make sure I didn't get, a broken pump. So
Right.
I checked it. Maybe like the only other way that I think that could have like happened was that the holes that I made in the tubing, maybe that was like sucking up air. And I tested that. I was just like, maybe it's this, right? I checked it without the tubing at all. And I put like the little inlet, I put the part of the pump in the inlet, and then the other part that was supposed to be for the outlet, halfway submerged. And I was doing the same thing. So I was like, well, it can't be the tube. Just like, I was just really confused. So I was like, I don't think there's a way that I could, this is gonna work out with the pump situation. And it just happened that like both of the pumps that was supplied to us had the same issue. So Not really sure what's happening there.
Okay. Did you discuss this with your lab partner?
Yeah, and he was just more as like lost as like I was because like we were pretty much doing the same amount of research. I was just
Did
like,
you discuss this with your instructor?
no, sorry.
Okay, you funny guys. You got to remember your instructor's a resource also. So you might not remember. Let's see, were you in the you were in the PLC class last year, yes?
Yes, yes.
Okay, one of the very first demonstrations I held for you guys in the PLC class was a relay controlled, a PLC controlling a relay, outboard relay, controlling 120 volt light bulbs. And so we were able to demonstrate putting on an AND function versus an OR function, one light bulb coming on, the other light bulb coming on, both light bulbs coming on. And clearly, as these light bulbs are 120 volt light bulbs, they clearly were not powered by the PLC, because the PLC is 24 volts DC. So if you recall how we were able to demonstrate that was I used a separate 120 volt line source, ran it through the output of the relay. The input of the relay was controlled by the PLC. The output of the relay that does the contact closure on and off was not powered through the PLC. It was powered through a separate AC rail, which upon opening and closing as it's programmed, turned the lights on. So the same thing could have been done here. The reason why your microphone was pinging on and off was because, yes, even though your USB is a powered USB strip, even then it has a limited amount of power that it can supply. So the moment that your microphone was going on and off while the relay was clicking on and off, is an indication that the Arduino is drawing a lot more power than you suspected initially. And we could have circumvented that by putting in a separate power supply for the pump. So the input side of the relay should have been controlled by the Arduino, which you have in place. The output side, rather than power it back to the, rather than create a power loop back to the Arduino, could have hooked up to a separate power supply. And if I recall correctly, you were part of the 56B power supply manufacturer class, and you have a DC power supply, correct?
Incorrect. I haven't taken that class yet. I'm taking it next semester though.
Oh, okay, well, some of your classmates in this class could have easily loaned you one.
Yeah, I had one on.
Oh,
Just couldn't remember if I had it.
Yeah. So the separate power supply would have been ideal to power the pump. So you create a separate loop using your power supply and the pump, but in that loop is the relay that is controlled by your Arduino. That way there's no current draw from your Arduino.
I didn't think about that.
Oh,
Yeah, and I just remember that I did a whole project on that for the PLC class.
yeah, you did. And you had to have a separate power supply because you couldn't run all the power through the PLC, just like you can't run, in this case, there was nothing wrong with the pumps because you bought two, you bought a backup, which was very prudent. You wired up one and it seemed to present some challenges as, oh, maybe I got a faulty one. You brought in the backup, you wired it up, and it presented the same challenges. So the issue was not the pump, other than the fact that it drew a lot of current. So remember, so the learning exercise from this is what?
I always have a second power source just in case, and test everything twice.
You'll see.
And don't forget you have resources with your instructors. So when we encounter things like this, we can all brainstorm this together and come up with a solution that will work. So I commend you for the amount of troubleshooting that you have been able to successfully complete and draw your conclusions that, yeah, we just flat ran out of power. And that's true. Yes, you ran out of power. And it was no fault of the motor, no fault of the Arduino. You just ran out of power. So now we find in retrospect, yes, we could have had a separate power solution. And that's our learning experience, which is, hey, you build on that. So when you get to the field, you'll find that get hired from different companies. And as they present you with challenges, the challenges are learning experiences. You're going to be able to successfully overcome most of them, but occasionally you're not going to successfully overcome all of them. And when that happens, that's a learning experience. So don't take it as in any way, shape, or form as a hit. It's not a hit. It's a learning experience. It's a learning moment, just like this. So it's not a hit. It won't ding your score on the presentation and your troubleshooting effect at all. It's a good learning experience. Anybody else have any comments that they'd like to share? Okay, good presentation. Thank you very, very much, Luis and Chase. Really love the project. Well done.
Good job.
Well
Good
done.
job.
Good job.
Woohoo.